Number 8. The Great Filter. The Great Filter was proposed by economist Robin Hanson to explain a simple but disturbing question. Where exactly is everybody? The universe is unfathomably vast and has been around for 13.8 billion years. Our galaxy alone has hundreds of billions of stars. By any reasonable calculation, intelligent life should be everywhere, but we see no evidence of it. This contradiction is known as the Fermi paradox, and the Great Filter is one potential explanation. The Great Filter theory suggests that somewhere along the evolutionary path from simple matter to galaxy-spanning civilization, there's an extremely difficult barrier that almost no species ever passes. Think of it as a series of hurdles that any potential advanced civilization must overcome. For us to be alone, civilizations must have not been able to overcome a hurdle. The terrifying question is, which one? There are two possibilities. First is that the filter is behind us. Perhaps the development of complex life or intelligence is astronomically rare. Maybe the leap from simple to complex cells happens on only 1 in a trillion planets. If so, we've already passed the Great Filter, making humanity incredibly special. We might be the first, or among the very few species to make it this far in our galaxy. The other possibility is that the filter is ahead of us. This is the darker one. Perhaps many species reach our current technological level, but something prevents them from advancing further. This could be self-destruction through nuclear war, climate disaster, engineered pandemics, artificial intelligence gone wrong, or some other technological catastrophe we haven't even imagined yet. If the filter is ahead of us, it means our most dangerous trials are still to come, and the silence of the cosmos might be a warning. Number 7. The Dark Forest. While the Great Filter suggests civilizations might self-destruct, the Dark Forest theory proposes that civilizations are actively sought out and destroyed. Any civilization that reveals its position does so at its peril. The theory rests on two simple assumptions. First is that all life has a survival instinct and will do what's necessary to survive. Second, resources are finite and civilizations cannot be certain of each other's intentions. Given these assumptions, the safest strategy for any advanced civilization is to destroy any other civilization it detects before they can become a threat. This creates a universe where everyone hides in silence, eliminating detectable technosignatures, because revealing your existence is essentially suicide. Under this theory, broadcasting radio signals into space, as we've been doing for decades, might be equivalent to shouting in a forest filled with invisible predators. The reason we haven't heard from anyone else might be because the smart ones are hiding, and those who weren't cautious aren't around anymore. Number 6. The Simulation Hypothesis. The simulation hypothesis suggests that what we experience as reality might actually be an elaborate computer simulation created by a more advanced civilization. The idea is that if any civilization ever develops the ability to create ancestor simulations, which are simulations of their evolutionary history populated by conscious entities, then they would likely create many such simulations. If many simulations exist, but only one base reality, the odds strongly favor us being in a simulation rather than base reality. This concept has gained traction among some scientists and tech leaders. Elon Musk famously claimed there's only a 1 in billions chance we're in base reality. Theoretical physicist James Gates has claimed to find error-correcting codes in string theory equations which, he suggests, could be evidence that reality has a computational foundation. Interestingly, some physicists have proposed potential tests for the simulation hypothesis. These include looking for glitches in the laws of physics at extreme energy levels, searching for computational artifacts in the fabric of space-time, or identifying convenient limits in nature that might be processing shortcuts. Number 5. The Transcension Hypothesis. Not all explanations for cosmic silence are dystopian. The Transcension Hypothesis, proposed by futurist John Smart, suggests that advanced civilizations don't expand outward into the cosmos. They grow inward instead. Rather than colonizing the stars, advanced civilizations may discover that the fastest, most efficient path to higher intelligence is to move towards smaller scales, faster speeds, and denser computational structures. Eventually, such civilizations might effectively disappear from observable reality, perhaps entering black holes or creating their own black hole-like environments that offer optimal conditions for computation. These environments would provide almost infinite subjective time and potentially access to other dimensions or universes. Number 4, the zoo hypothesis. Perhaps we don't hear from alien civilizations because they've deliberately decided not to contact us. This is the essence of the zoo hypothesis, first proposed by MIT radio astronomer John Ball in 1973. This theory suggests that advanced civilizations might be following a policy of non-interference with developing worlds like Earth. They might observe us like animals in a zoo or a nature preserve, studying our natural development without influencing it. The zoo hypothesis suggests we might be under some form of cosmic quarantine, with Earth possibly marked as a no-contact zone. Perhaps there's a galactic equivalent of Star Trek's Prime Directive, which is a rule against interfering with pre-spacefaring civilizations. Number 3, the Berserker Theory. On the darker end of the spectrum, the Berserker Hypothesis suggests that self-replicating machines designed to destroy organic life might patrol the galaxy, eliminating civilizations as they emerge. Named after the Berserker book series, this hypothesis proposes that these machines might have been created long ago by a now-extinct civilization, either as weapons against enemies or as misguided protectors programmed to eliminate potential threats. Once released, these self-replicating machines would continue their mission indefinitely, reproducing using materials harvested from asteroids and moons, and methodically sterilizing any planet showing signs of developing intelligence. Such machines would likely be programmed to remain stealthy, hiding in asteroid belts of the star systems they monitor. They might wait until a civilization develops radio technology or other definitive signs of intelligence before striking. These machines could attack at any time as we continue broadcasting our existence to the cosmos. The theory also implies that any sufficiently advanced civilization could create such machines, meaning this threat might emerge independently in multiple parts of the galaxy. Number 2, rare earth hypothesis. Moving to more optimistic territory, the rare earth hypothesis suggests that while simple life might be common in the universe, complex multicellular life is extraordinarily rare due to the precise conditions required. Proposed by geologist Peter Ward and astronomer Donald Brownlee, this theory argues that Earth has benefited from an improbable series of fortunate circumstances. Our sun is unusually stable and has the right lifespan. Earth is in a perfect Goldilocks zone for liquid water. We have a large moon stabilizing our axial tilt, giving us stable seasons. Jupiter's gravity protects us from excessive comet impacts. Our magnetic field shields us from solar radiation, and Earth has the right mix of elements for complex life. According to this view, the evolution of complex life requires such a precise combination of factors that it may have happened only a handful of times in our galaxy or even the entire observable universe. This theory suggests we may be effectively alone, but not because of impending doom. Rather, we might be one of the few planets lucky enough to win the cosmic lottery. Number 1, Panspermia. Here's a twist on our cosmic origins. The theory of panspermia suggests that life on Earth didn't originate here at all, but was seeded from elsewhere in the cosmos. According to this hypothesis, microbial life can survive in the vacuum of space, especially when protected inside asteroids or comets. These microbes could travel between star systems, effectively spreading life throughout the galaxy. There are several variations of this theory. Lithopanspermia, where life travels inside meteoroids ejected from planets by asteroid impacts. Directed panspermia, where intelligent beings deliberately seed life throughout the galaxy. Ballistic panspermia, where life spreads within solar systems via impact debris. Radioactive panspermia, where radiation pressure propels microorganisms through space. Some evidence supports the plausibility of panspermia. We know that some bacteria and tardigrades can survive in space. We've found amino acids, the building blocks of life, on comets. and Mars and Earth have exchanged surface materials through asteroid impacts. If panspermia is correct, then it would mean that we are all extraterrestrials. Our ancestors would be from the stars, not just in the form of elements forged in stellar furnaces, but as actual living organisms. That's all for today, and thanks if you made it this far. Please like and subscribe if you enjoyed the video, and let me know what topics you'd like to learn about. See you guys next time.